Hello friends, welcome to Data Science Learner. We have started a new playlist Machine Learning in which we are going to cover A to Z topics of related to machine learning. Here we will cover the concepts, mathematical intuitions, logics, coding, etc. etc. Like one place for every machine learning solutions. So guys, in the first topic, we are going to deal what is machine learning and what are the types of machine learning. So the agenda for this particular video is to give you the in-depth knowledge related to machine learning and its type. But before I start, obviously you would be having some questions into your mind that why machine learning? Why can't we write code like in general traditional coding we do? What is the difference between general coding, developing algorithms, and machine learning approach? Which type of problem we try to encounter with machine learning approach? So guys, let us take an example. Suppose that you want to build a software for checking the capacity of an applicant to get a driving license or not. Suppose that you are a software developer and trying to write a software for this. See, it would be very complex in logics and you would be end up so many rules into it. Now the problem is that even though covering a lot of rules, that would not be exactly accurate, because some of the decision which our human mind thinks there is no thresholding. I mean, we don't estimate our mind is that if we need to consider 80%, 80 things that we are looking into a person to provide or approve him for a driving license, in which he is excellent in 50 things and good at like 20 things. We don't do like that. Whenever we make decisions, it's like some complex operation happens inside the mind, and if you try to write, it would be completely rule based, and even for a small mistake or a small thing, a applicant can be disapproved from the software, and it will be a big noise. I mean, it will be a big failure if you try to solve that particular thing with your complex code, right? And even though for writing code would be like too longer, a lot of testing that is required. The easiest way to approach this problem is to hit this thing with machine learning. When I say machine learning, it means you are capturing the observation, whatever the factor that you are taking care of, you need the values of those, and based on that, on the historical level, you capture the data. I mean, you capture the observation where a person is approved for a driving license and a person is disapproved for a driving license. And then you develop a machine learning approach which automatically understand the pattern rather than brainstorming, thinking a lot, having n number of people. A small team, a single data scientist can build up this model, and that is acceleration in the term of delivery. And that's why we pitch in machine learning, where we can take data driven approach, where your program automatically understands what your data says and develop logics using numerical terms into the processor, and it automatically tell you the things. So guys, this is machine learning. Now a lot of problem that you see that like in computer vision field, natural language field, where you are speaking and your computer is capturing your voice, voice control things are coming. This is all happening because of machine learning. Self-driving car, it's like miracle, but that is only possible with the machine learning. So I hope that now we have understand what is machine learning and why we need machine learning. Like definition wise, it's a field of computer science where we need not to explicitly write code to build logic and rules. Here the program itself identify the pattern from the past available data and predict the things. This is a data driven approach. This is a simple definition of machine learning. I hope we are clear. Moving to the next section, where we'll see what are the types of machine learning. So broadly, machine learning has three types: supervised machine learning, unsupervised machine learning, reinforcement learning. So to overview, whenever in the training data we have the labeled output. Suppose that you build a model to predict a person has cancer or not, where the label is available that cancer is cancer has infected the body or not. This is like labeled data. You build up a model for driving license applicant is approved or disapproved. Here your approval and disapproval 0 or 1 or A or B selection or class. So this particular is a label data where you know the output already in the historical things. So this type of modeling and machine learning is called supervised machine learning. Now moving towards unsupervised learning, here the objective is to find the similarity in the observation. Suppose that we have two customers or like 1,000 customers in which I need to create a user segmentation. I want to identify the similar type of users, but I don't have any labeling so far. So what I will do, I'll use the unsupervised learning, which automatically cluster the things into segment and solve a lot of real-time problems. So guys, we would be preparing the playlist. Obviously, we would be going to unsupervised technique and then creating algorithms, solving real-time projects. But for this video, we are going to cover only the definitions. And then the latest and the most powerful is called reinforcement learning. This is like real AI which you imagine. Here, we take the user feedback, positive or negative, and based on the policy, we give the reward to the system. I mean, here we need either no training data, less training data. As the user is behaving, suppose that you build up a recommendation model using reinforcement learning. Now your model is suggesting something randomly to your user. If he's liking, then obviously this kind of similar recommendation would be coming. If he's disliking, so like he will, automatically your program will understand that what is the taste of a user. So this is like reinforcement learning. This is interactive in nature. This is interactive in nature, and like where we have more complex and labeling the data will take a lot of time. We generally go with the reinforcement learning, right? So obviously when I go with the type, so in supervised learning we do either classification or regression. Let me clarify that into the next section where we will deep dive into each type. Obviously example I have already covered, like sentimental analysis. Any kind of classification we do is comes under supervised learning, and a segmentation come where we have no labeling data. Then it goes under the unsupervised learning. Reinforcement is like self-driving car. Complexity wise, guys, these are medium and industry in the standard right now. A lot of consulting companies and product based company are relying on supervised learning and supervised learning, but few of the big giant companies are also focusing on the reinforcement learning. So this is the gist what type of machine learning we have generally. Now we will deep dive into it. It's not like it's just a differentiation. If I go, so to understand more on the supervised learning, let me make you clear. So suppose that I build up a data where three of the column, X showroom price, age of the car, and brand of the car is like input feature, and then based on that is I'm predicting the resale value of the car. Now this is the label data. In the past, this type of features, if a particular car has these three features, the resale was 2 lakh or something. So this is like label data where we know the output, guys. I hope it is now clear. Where in the past what was the output, then it is called supervised learning, and you prepare and end up with the training data. So basically definition wise, if the training data contains label data, then it is supervised learning, where we label data means defining outcome in the historical data. Now on the basis of label data, we can further classify the supervised learning. So supervised learning has two paradigms basically. What are those? One is classification, one is regression. So if you look like this price, this is continuous in nature. When the output label data is continuous in nature, then it is regression. It's like forecasting some price, forecasting some sales, forecasting any numeric thing, then it's regression. If the output is continuous in nature, then it is it is regression. When the output is categorical in nature, then it is classification type. supervised learning. What it is? So basically, if you want to create a program for loan approval, where the target label data, output data is like approved or disapproved, 0 or 1, or multiple class it can have, that all comes under the classification. So like any yes no type, creating the output into classes, everything comes under the classification. And guys, we are going to develop each and every algorithm inside the classification under the machine learning. So I'll definitely ask you to subscribe our channel so that you don't miss any kind of the informative things. I hope now we are clear with the supervised learning. Now the next type is unsupervised learning. What is unsupervised learning? Obviously no label training data. So if the training data contains no labeling, then the final agenda is to build a model to identify relationships in the data point to create clusters. So for example, I have the data for 10,000 user and I want to bucket them into some segments so that I can run some market campaign. So for example, I have 10,000 customers, where 500 customers are very interested into luxury product, and like 5,000 customers are like buy daily product, or where the prices are not very high. So suppose that I build up a campaign and I just cluster them, and then I target 500 customer and send them the luxury high end product to them. Obviously there, that will end up to the more sale. So how we do that? So basically this is the data set, and then I identified using some clustering algorithm that this particular observation and this particular observation has more similarity, and then I just created a cluster of these two record and put them into a cluster. So basically, like these two are mapped to this particular cluster. Maybe this particular first record or fourth record, this can move to the different cluster. Basically, bucketing the things. Without labeling, you are bucketing into the clusters. Unsupervised learning applications. Obviously, you would be thinking that what are the applications that we can build them into the real-time world. So the applications are user segmentation, as I told you, market basket analysis. Here, say suppose that your company manufactured 1,000 product, but if you keep 3 products all together, the sales are high for each other, because suppose that if somebody goes for purchasing bread, obviously you put milk around it, then definitely he or she can end up with this like milk and then bread all together. So this type of thing comes under the market basket analysis. Anomaly detection. So for example, you have a list of transaction, 10 million transaction, but few of the transaction are fraudulent, or like seems done for frauds. So if you want to extract the information, but obviously you don't have the label, then it comes under anomaly detection, and here we detect the anomaly. News clustering. So suppose that you are you build up a program, a crawler, which just end up crawling news for you, and you want to build an application where user can go and see the news, but user want to see them into the categories. Now if you don't know the categories, what you can do, you can use clustering to put similar news all together. So suppose that if I'm a cricket lover, I'm reading some news for cricket. Obviously, if there is another news related to cricket, I will invest time into that as well. But suppose that I am a cricketer lover, and then you just recommend me a news which is belonging to the politics. Obviously, I'll not like that. So this type of application we can easily build with unsupervised learning. Market campaign target customer. Obviously, I told you, if you segment the customer in proper bucket, so your strategy, whatever the market strategy you are targeting for one particular segment, can end up into more sale, more influence, rather than sending generic things to all the customers. And it saves a lot of time, because here you don't need to label the data, so a lot of effort can be saved. So I hope that we are clear with unsupervised learning, and if you have any confusion on into the definition, overview, or application, definitely you can comment back into our comment section, and we'll love to revert you on that. Last but the most power algorithm is called reinforcement learning. It actually works like a human learning works. Basically here, if there is no label data, and creating label data is not possible. Assume that you want to build a self-driving car. How many label data you will create? How will you train your model? I mean, it will be very, very difficult. So it works how a child learns the things. Basically, he listens something, act something, and based on like the people available in the environment, like it is positive or negative, people give him the feedback, and he started learning the things. Same approach that we do with the machines as well, where it works on the principle of reward. So I have one simulation for this. So for example, you are an actor. Actor means somebody who is just reacting. He takes some actions. His action can impact the environment. Now I have a policy set, like it is which type of reward I can give for an action done by actor. It could be positive or negative. In the same way, it in the interactive mode, I keep on training. I keep on training and building the complex, sophisticated system without labeling the data, and it is called reinforcement learning. A lot of robotics, lot of self-driving car or amazing application is coming on this paradigm technology or basis. So I hope that this is clear to you. Application, again I told you that the self-driving car, feedback based recommendations. So for example, I told you that you open some application and some new product launched, and your system somehow recommended to you, but you did not invested a lot of time looking into it. Obviously it get the negative feedback, and then he again throws some other things which is new, but you were interested. Then your model will understand automatically. In past, it does not have any data for your behavior for that particular product, but based on your uh, interactive interactions with the model and software, so it understands and it started training the model. Adopted adaptive completion test. So for example, if you are doing good with a competitive exam, there are a lot of competitive exam. If you are doing good, then the upcoming questions become tough, because they want to test what is the threshold of your IQ. And if you are started answering questions incorrectly, it means the exam should go to the below level, because it is adaptive in nature. It's not like 100 questions are fixed for you. It's like if you are intelligent, then how much. So if you want to build up the complex things, obviously you can do only with this, the help of reinforcement learning. So this is all, guys. We have covered what is machine learning, why we need machine learning, what are the types of machine learning. If you like this particular video, share with your friends, and obviously we would be keep on creating videos like this, complex terms into the simpler language, into data science learner. Follow our blog as well, subscribe us, comment us, like us. Thank you so much.